So, good morning one more time. I'm Ilona Faustova as a program director of Bachelor Degree Science and Technology program and Master's Degree program Bioengineering. And as our seminar topic states, there are three factors which are important for circular bioeconomy: R&D, talent, and technology. So our research and development requires technology advances and vice versa, but both need talents. So here is a very important role in universities, because to get a multidisciplinary specialist, we need to educate students. And it's always also beneficial when enterprises give their input into education. So we can prepare for further career students, talents with required skills and knowledge for the work market. And good, effective, and innovative education incorporates the trends and advances of research and development and technology, and also take into account the input of enterprises. So in 2015, we launched the bachelor degree program, Science and Technology, and as a follow-up of it, the master's degree Bioengineering program in 2018. So the first admitted students to bachelor degree program could continue their path in master's studies. And we are having yearly up to 232 applications for the programs, and during the COVID and war years, the number of applications a bit decreased. So on average, we have 175 applicants per year. And in total, for two programs, we have 65 study places, 15 for master's and 50 for bachelor degree. Graduation rate is higher than university average on both programs. So during the years, from 2015 year, on Science and Technology program and Bioengineering studied 495 students from 51 different countries, from 5 different continents. So it's very diverse, and our alumnus are everywhere in the world, and our network grows very fast, and it's really wide. At the moment, on the program study 151 students, and 88% of them are international students. So Science and Technology program, bachelor program, is coordinated by Institute of Bioengineering, but it's in collaboration of 4 institutes: Bioengineering, Technology, Chemistry, Institute of Molecular and Cell Biology. And the aim is to get talented students from around the world who are interested in life and exact sciences and have interdisciplinary mindset. This program, a Science and Technology program, has 3 specializations. It's bioengineering and robotics, it's chemistry and material science, and also genetics and biotechnology. But first 1.5 years, all students are studying together. They are getting basic knowledge in the fields of math, chemistry, physics, programming, molecular biology, all these basics what they need in further studies. It doesn't matter what specialization they will choose. Also, they're getting a lot of practical experience in the specialization field, because usually when you graduate from high school, you have pretty abstract imagination of this specialization. So it's better to try before you choose. And after having all this practical experience and getting basics, students are doing their knowledgeable decision about specialization based on acquired knowledge and skills. So, and next 1.5 years, they study already separately according to the interest on the chosen specialization. And already on the first year of bachelor studies, students are getting, for example, introductory laboratory course, which combines lab tasks from 5 institutes. And also on the first course, bachelor students are doing laboratory project course. They're doing 3 projects in 3 different institutes. So it makes easier again to make a choice, because during the doing of these 3 projects, they have the possibility to try different specialization in real life, to work on actual research project and learn to analyze data, and they're getting experience in scientific presentation. So all what requires to make a choice of specialization. And the structure of this curricula is providing better career decisions, because you are doing already the decision basing on your own experience and what you wish, what you like. Also, students getting solid foundation in various fields. And at the beginning, students are studying all together the first 1.5 years. So it initiates the growth of community of future multi- and interdisciplinary professionals. So a lot of advantages of this structure. And also the collaboration with enterprises is very beneficial. We have collaborations in both programs, master's and bachelor programs. We have practical courses in collaborations with enterprises. Professional practice can be done in enterprise, and even there is a possibility to do the joint graduation thesis. So it provides the opportunity to better prepare the specialists with the set of required skills and knowledge for the future job market. And after graduation, our alumni are wanted in all over the world in top universities, and they have possibilities to continue in academy or enter the job market, or some of the students sometimes switch the specialization, and it's also possible because solid foundation knowledge and skills can be transferred to other professions as well. And in our both programs, we use active teaching methods philosophy. As Chinese proverb says, that what I hear, I forget, what I see, I remember, and what I do, I understand. So we are trying to follow this philosophy, and we are using a lot of different ways of receiving new information. So these are seminars, group work, team-based learning, project-based courses, practical courses. Interaction of students with the subjects of study provides practical courses. So we emphasize in our program practical courses, because you develop your skills and knowledge the best when you are doing by yourself some practicals. And you have the opportunity to incorporate newly acquired knowledge in practice, doing some practice in research groups, in enterprises, or while doing graduation thesis. And also, we pay attention to creation of encouraging study and atmosphere, which is also very important, because when students are feeling welcome in studying environment, they have feeling of belonging and emotional support, then they are more motivated, they're inspired, and the overall study outcome grows exponentially. And do not underestimate emotions input on the studies. If students are getting positive emotions, again, motivation raises and increases, and study outcome as well. And opposite, the negative emotions decreases motivation and study outcomes. And here I'm not talking about failing the experiment of getting a bad grades, but negative study environment. It influences a lot on the study outcomes, because if students don't want to come to university, don't want to come to classes, then it means that he will not have a desire to study. And if combine all of this active teaching method, one of the best examples is iGEM course, what we have. It's not just a course, it's the largest synthetic biology competition in the world, but we use it as a teaching tool. And in this iGEM competition, more than 400 teams participating from all over the world. It's more than 66 countries, different countries and regions every year. And students work over the season on the project, starting from spring till autumn. And this iGEM finishes at the Jamboree conference in Paris. So the main aim of this competition is that you take any world problem and you offer the solution with the help of synthetic biology. And this competition had a lot of parts, a lot of activities, tasks, what students has to do during the project. They starting from creating an idea, brainstorming, they work on the project, they document the work, doing attractive website, which will be judged by judges, and everything is ending up on the Grand Jamboree conference, where students present the project, they defend the project, and also compete for medals and awards. And as this competition has a lot of different tasks, and all these tasks are equally evaluated by judges, so a lot of different skills are developing during the competition. So students develop lab skills, computer skills, writing skills, and which is also very important, soft skills, because soft skills are very important also for future career. And as an example, students have to contact with experts, stakeholders, get feedback and incorporate it into the project. They have to raise awareness of society about the problems. They have to engage public, raise interest towards the science, doesn't matter what age or profession people are, and to fulfill all the tasks and be successful in the project, they have to have very good teamwork skills. So teamwork skills also developing during the project a lot. And our first Estonian iGEM team was launched in 2017, and during the years we got some silver medals, some gold medals, and the first bigger achievement was in 2022 when we got the Best Wiki nomination. And last year, 2023, our team achieved unbelievable success because the team managed to win the grand prize in overgrad section of the competition. It's the biggest possible achievement what you can do on this competition, and it means that a team and the project was chosen to be the best among hundreds of teams, thousands of participants, and the iGEM team brought the triumph to Estonia. So at the same time, the team got awards as a best project, best measurement, gold medal, and was nominated as best wiki, best education, and best presentation. We are often joking with the students that there is a life before iGEM and after iGEM. And it's really true. During the iGEM, the motivation and eager to study increases a lot in the students. And it's not only in the field where they improve study outcome, knowledge, professional skills, communication and teamwork skills, but the improvement is overall in all studies, in all courses. Now, for example, I can bring an example that our student before iGEM had a GPA 2.5, and after iGEM he raises increased GPA till 4, continued studies in master's studies, and graduated within 1 year with cum laude. And now he's doing PhD project. So it's not the only one example, but all these examples prove that incorporating of such active teaching methods into the curriculums is very important, very beneficial, and is necessary to get very good, skilled, professional, multidisciplinary specialists. Also in master's program, we are using the same principles as in science and technology. We emphasize practical skills, and in the course, in the program, we have only 4 compulsory courses, so it makes possible to choose a lot, to be very flexible and choose program according to the interest, according to the topic of the master thesis, and be more free in the choosing the courses. So the program has also plenty of practical possibilities, including some practical courses in collaboration with enterprises. And as we already mentioned, it's very beneficial because it provides the required set of skills and knowledge which in future is needed on the world market. And after graduating from bioengineering program, there is a possibility to continue studies on PhD in academia or in industry, enter the job market. And if a student want to do the PhD in industry, it has a lot of beneficial sides, but there is also complications. And Priit Jõers is as a representative of both sides, academia and also enterprise, has experience with both sides and can tell a bit more about his experience with PhD studies.
Well, thank you, Professor Faustova. So I will indeed give you a short overview of my experiences, the ins and outs of having a doctorate students in the company. So, as you might remember from my yesterday's talk, I'm the CSO of BiotaTec. And according to the statistical webpage of Tartu University, the University of Tartu has approximately 1,100 PhD students listed. I don't know how many are they actually active or not. And it accepts something between 170 to 200 new PhD students annually. So that number up there is pretty stable, which means that the influx and outflux kind of balance out each other. Now in 2022, University of Tartu launched a new and improved industrial doctorate studies program aimed to foster contacts between university and private sector. So according to the fresh from the oven statistics that I obtained, there are currently approximately 30 industrial PhD students in the university. And university has a strategical goal to increase that number to 100 by 2025. Let's see if it actually materializes. But out of this 30, only 5 are employed as junior research fellows in the University of Tartu, like regular PhD students. And the main cause for this is that once you work at the university, according to the under this program of being a junior research fellow, the university owns basically your IP, which is of course difficult not to swallow for companies. So the rest 25 are working in companies because of those intellectual property agreements. Now, 2022, once it was launched, or actually even a little bit before that, BiotaTec encouraged 2 workers with master degrees to enter this PhD program. Astrid Laidna, Astrid Salumäe, now Astrid Laidna, and Jaan Vihalem. So what does it actually mean to be an industrial PhD student? It doesn't actually differ that much from the generic PhD student program, which means that students still have to go through the University of Tartu program, take lectures, and collect EAPs, right? And if you're working in the company pays for all the costs, salaries, and all the associated costs linked to the actual research that they're doing. Obviously, this is a balancing act, because if you're working in the company is a profit-seeking entity, but at the same time, we have to keep in mind the way that we need to foster or help them to finally obtain the degrees, because there is this 3-document requirement, which still is a little bit fluid. I think it might be actually subject to change. What exactly are those 3 documents required from the industrial students? There has to be at least, obviously, 1 article with the first authorship, but the rest 2 might be articles, patents, process descriptions, etc. Now, in our faculty, the average time for graduation is way above 4 years. It's 5.5, actually. And I mean, usually it's linked to these 3 publication requirements. Groups kind of like publish at different pace. So some groups cannot make the cut. So it basically has to, the doctoral student has to publish 3 papers in 3.5 years in order to make the 4-year cut, right, with his official defense time. But actually working in the field of bioleaching, which is in our case is largely focused on the rare earth elements, it actually provides a unique challenge for graduation. Because when we're talking about the rare earth elements, there's one country that dominates the rare market. It's partly because they have won out in the geological lottery. They have a lot of rare reserves. Plus, there is a politically backed, decades-long strategy to dominate the rare market. And as you can see, that unnamed country has really sort of dominated since the mid-80s, and it basically has taken over the rare market. And that country imports something like 98% of the Europe's rares, right? And this, of course, creates issues for EU's long-term supply of these critical raw materials. If you rank all the materials by the supply risk, the light rares and heavy rares are really at the high end of the spectrum. Now, the issue is that this country has a record of not respecting IP rights and patents. Because once you publish patent, I mean, this is public, right? So everybody knows what you're doing. And to litigate this patent theft will be very expensive with highly negligible outcome in that country's courts. Which means that we cannot risk this, telling everybody in the world what we are actually doing and how we are doing it before we have netted a large client. So here you actually can see the one, sorry. Here you actually see this one stack of phosphogypsum, one of those industrial waste streams that I told you about. And that line here is a road. And that dot here where these kind of dump trucks actually run. So that gives you the scale, again, the scale of the operations, meaning that what I'm trying to get at, that if we can net the client that has these kind of stacks, you understand that then we are safe to publish the patent. Because even if that unnamed country steals it, we are kind of like safe. We have made money on this. We can take this. But obviously, this needs to be postponed until we have netted this. And that might actually have a significant negative impact on the graduation time. And if you take a view from accounting, without disregarding all this kind of fostering young people's career, then the view from accounting might be that BiotaTec funds all work and salaries, but the lectures and exams take up work time. So, which means that some resources are diverted towards the completion of PhD work without immediate impact to this strategic goal of the company, which is, of course, is seeking profit. But I don't want to, beside this kind of accountant view, I would say this is definitely a positive thing. Because in the bottom line, if you can actually do this kind of industrial PhD programs, it helps company to attract talent and also motivate existing employees. And believe it or not, we in the BiotaTec actually think about these things like how to support the academia, because it gives us a possibility to kind of fuse with the existing curriculum and perhaps enrich this with the practical experiences and lectures. Now, and to take 2 or 5 steps back and look at the big picture, I would say that this is a positive, completely positive thing from the viewpoint of the whole society as well, because it creates a highly qualified workforce with a real-life experience in working for a profit-seeking entity, which means that it prepares people for the future careers in the private sector. And in the end, if you have this highly qualified workforce, that results in the diversifying Estonia's economy, which is an absolute must if we are to live better lives in the future. Okay, thank you.
Yeah, maybe someone has questions? So if not, then let's go.
There is one question.
Oh, sorry.
Is there a mic? No, I can speak loudly. All right, thank you. So question, what are the quality criteria that have been set for the company supervisor? So who can become an industrial PhD supervisor from the company side?
Well, I mean, you got to have the PhD degree, obviously, but that's about it. It's up to the company to decide.
But
Obviously, I'm the PhD supervisor from the company side.
and you definitely have to have a co-supervisor from university side,
Yeah,
because it's like as a provement that the work is PhD level.
Since I hold the associate professor degree in the biochemistry, I found out that I cannot represent both sides, unfortunately.
Yeah, because you have the conflict of interests.
Well, I don't see the conflict in there. But